Hey guys, welcome back to the channel. My name's Jude. Today we're going to talk about tuning the sound system to work with the natural acoustics of the room. With the advent of digital processing, a lot of what's done now is automated. But I want to show you, using analog equipment, how we properly tune the sound system to the room using a third octave equalizer and then using a parametric equalizer to notch out the feedback frequencies and give us greater gain before feedback. A well-tuned room will sound great. So this is my sound advice on tuning the sound system. We have our third octave equalizer. This is general shaping across the audio spectrum. It's 31 bands, so we have 20 to 20,000 hertz, and it's divided into 31 bands, so it's a third of an octave. Next we have a notch filter, or a very narrow band. We can tune out individual notes on a piano. We can tune as tight as 1/20th of an octave, or as wide as 1/3 of an octave. We use this piece of equipment to pull out our feedback. When we tune, first thing we do is shape the sound to the acoustics of the room, and we'll use the third octave equalizer. On a side note, if you've ever seen a third octave that looks like this, we'd call that a smiley face EQ. Or if you see a third octave equalizer that looks something like that, right off the bat you can tell that that is out of adjustment. So when tuning, the first thing that I do is I will set everything to 0. With this third octave equalizer, there's a detent right at 0. On the master section we have 3 buttons. We have a 40 Hz roll off in and out. We have a plus or minus 6 or plus or minus 15 dB range, and then we have just an in and out. We have our master volume, so if we need to make up a little bit of volume on the output of the third octave, we have some makeup gain here, or phantom gain. When starting off the tuning, I need to know what the limitations of the speakers are, and then also the application of the tuning. This is primarily a speech system, and then it is a distributed ceiling system. We have about 40 8-inch coaxial ceiling speakers in this room. The roll-off on the low end for those speakers is about 80 Hertz. So what I'm going to do right off the bat, I'm going to knock off all of these low frequencies. Those speakers aren't rated to handle any of this content, so 2 things. I'm going to use less electricity in the amplifier, and then also I'm going to help protect the speakers so I don't overdrive the woofers and then possibly cause distortion or rip the woofers apart. So my range of the speakers that I want to work with is 80 Hertz to 20,000 Hertz. Now those speakers tend to roll off more about 15,000. So I'm going to take the 20K and I'm going to roll it completely off, because in this application that's just going to be hiss or just really high static. In speech, the areas I'm very concerned about is the 2,000, 3,000, 4,000 Hertz range. This is what I'm going to be very mindful of. This is where we get the intelligibility from our consonants. Most rooms are going to give us problems 200, 300, 400 Hertz. This is going to be a lot of problems that the room's going to cause. And then also the speaker is going to have some deficiencies, and so you'll see the tuning will be up and down across the 31 bands. When tuning, we need to have a reference sound. So we have what's called pink noise. That is our reference sound that we're going to run through the system. So on the iPad here, I will have pink noise turned on. And then I'm going to turn down the level. We're going to turn that on. And I have the volume down here on the fader real low. I'm hitting PFL to make sure I'm not going to distort the input of this channel. So I have that at 0. The channel's at 0. I'm going to take 4 measurements around the room with this analyzer, and then I'm going to sum those measurements together, and then that will give me my tuning that I need to start with on the 3rd octave. So let's go take some measurements. Now that I've taken 4 measurements scattered throughout the room, I'm going to average those together. So I'll hit the average button. So I'll hit 1, 2, 3, and 4, and then I will average those, and I'll store them in A. Now I'll go to EQ setting. That's going to show me on the 31 bands what I need to be working on. So we're saying at 80 Hertz, it's recommending that I pump it up 13 dB. I'm not going to. 100, bump it up 10, and then 125 plus 4. So there, let's start at the first one that we're going to actually be subtracting. So 1.6 dB drop at 160. So 160, 1.6 dB. So 160 I'm going to drop down. 200 minus 6. 250 is going to be minus 4.4. 315 minus 4.5. 400 is going to be minus 1.6. 500 minus 1.5. 630 minus 1.8. 800 just barely down at 0.4. 1K 1.6 down. 1.25 minus 1.1. 1.6 minus 1.8. 2K minus 0.4, 2.5, again just down just a little bit. Now at 3.15, it's saying we got a deficiency, so it's saying plus 2.4. So I am going to work with some of the lower frequencies here, or some of the higher frequencies. I am going to raise them just a little bit. So 3.15, I'm going to bring up 2. 4K, saying bring up 4.4. Now remember, I told you this is the range that where we get our speech intelligibility, 2, 3, and 4,000 hertz. So that's why I'm willing to do a little bit more work of raising up the volume here. 5K is going to be plus 4.4, 6.3, so it's saying 6.9. I'm going to hold off there. So now that I've done my first shaping on the 3rd octave, I'm going to go back and take 4 more measurements, and I'm going to see how we did here. Okay, let's see what we come up with here. And so we're still saying we need to bring a little bit more down, so I'm going to do a second tuning. Okay, so 160, we're still going to come down 2.5. 200, 7.9. 250 minus 3.9. 315, 4.3. 400, 1.9. 500, 3.6. 800, 0.3 down. 1K, 0.8 down. 1.25 is now, I need to bring that up. 1.6, we're going to bring down 3 decibels. 2K, we'll bring down 4.4, so just a little bit. 2.5, 0.4. 3.15, 2.4. 4K, 4.1. 5K, 4.6. And I'm going to hold off there. On your shaping, general rule of thumb, you want to always cut before you ever boost. Anytime you boost, you're going to add the potential for feedback problems or overdriving the system at that specific frequency. So most of the shaping that you'll ever see me do is I'll do cuts. When we're at 0 here on the 3rd octave equalizer, this big bold white band, we're neither adding or subtracting electricity at that frequency. So if we pull the fader down, we're cutting the amplitude at that frequency. If we bring the fader up above 0, we're adding amplitude at that frequency. So now you can start to see just general shaping of the EQ. We're doing again a boost here because again I want to make sure that the frequencies that we hear most efficiently at and where we get the fidelity of the consonants, right there, our S's and our T's, the sizzle, I want to make sure that that always punches through the clutter of the room to where our ears can understand what's going on. So now what I'm going to do is I'm going to test it with the microphone to see how it sounds, and I may analyze it again to see what it sounds like. 1, 2, check. 1, 1, 2, 3, 4. Proper planning and procedure. 1, 2, 1, 2, 3, 4. 1, 2. Which is pretty amazing. I don't have any notching on the system yet to take out the feedback, and I'm walking right under speakers and not getting feedback. That's one of the difficulties of a distributed system. There it is right there. 1, 2, 1, 2, 3, 4, 1, 2. So making sure that we have a good uniform sound of my voice. There's another speaker right there. 1, 2. Check 1, 2, 3, 4. 1, 2. Barely starting to ring. A properly balanced room acoustically will give you more headroom or more gain before feedback right off the bat. 1, 2. Check, check. 1, 2. 1, 2, 3, 4. 1, 2. Now I'm going to pull out the feedback of the two microphones that are used in this room, which would be a handheld and a lapel or lavalier. The air wall or operable wall is up, so I got to go out in the hallway and then come back in. So I'm going to set the two microphones up where they're going to be used in the room, which is going to be on the stage area. I have the Shure lavalier and then the Audio-Technica handheld. I'll clip them onto the mic stand as if we were using them in this live application. We're going to notch out the feedback frequencies of this microphone and then the lavalier or the lapel microphone. I'm trying to simulate if it was on my tie or suit coat, so that's why I have it clipped right here. And then our first set of speakers are going to be right back here. So this system, these microphones are never designed to be used directly under a speaker. So in the stage area, there's no speakers, and then the house speakers are behind me. I'm going to slowly bring each microphone, let me get rid of the gum. I'm going to slowly bring each microphone into feedback and then notch out those frequencies. And that will give our system more gain before feedback. I'm going to make sure that our EQ is flat. I don't want to get any false readings. So good gain there. I'll set the gain up right there. Flat EQ, high pass filters turned on. Nothing wild. Those channels are turned on right there. I'm going to start with the lapel mic. So I'm going to bring it into feedback. And then I'm going to find those frequencies and notch them out. I'm taking out the old notches in this system and then turning off each filter. I am ready to bring the system into feedback. I'm going to turn on this top bank filters. Now let me explain how this works. This is a typical filter on this notch filter set. We have a gain, so I can either add volume or subtract volume at that specific frequency. We have this post right here, which actually selects how wide or narrow the notch is, so that's a 20th of an octave. So do we have a very wide notch or do we have a very tight notch? So most of the notching I'm going to do is going to be on this side, 20th to 15th of an octave. And then this ring right here, that selects the different frequencies that we'll be working with. So you can see there's 500, 1K, 2K. So through this gain, I'm going to turn the volume up, bring the system into feedback. My iPad's going to tell me what frequency is feeding back, so it's going to give me a frequency number, and then I'm going to notch it out. .624. So I'm going to keep the feedback going. Turn on this bank, and I'm going to cut 3 decibels, and then I'm going to dial this down to 624. You'll hear the feedback go away. Right there. And I'm at a tight 20th of an octave notch. Now I may need to come back and widen that notch a little bit later if we have some neighboring frequencies. So now I'm going to turn the gain up more. There's our first. Now we got a neighboring 420. So I'm going to take a little bit more. There's that 420 coming through. So I'm going to do the same thing here. Turn this on. Do 3 dB cut. We're going to come down to 420. Right there. So I'm doing these notches in 3 dB increments, trying not to over equalize. I'm going to widen the first notch, and I'm going to do a little bit more of a cut. Okay? So now between those two notches, I've just done 3 cuts. Now 2 frequencies coming in, a higher and a lower. 1574. Going to do 3 dB cut. Now we got a lower one. A 172. Now to get into that frequency, I need to divide it by 10%. So even though it shows that we're almost at 2K, I hit this divide by 10%, and that lowers that ratio, so I can do a lot of fine-tuning from 20 Hertz to about 200 Hertz. Okay, you can see how much gain we've added. We've added probably about 10 dB of gain just doing some notching. So we had a 15 and a 17, so I'm going to widen the 15 out. It's not going to do it. We have 5 notches on the lapel. 1, 2, 3, 4, 5. Now what's that coming in? About 2,000 Hertz? 24. Okay, so I brought that back down to 0. And I'm not doing anything too aggressive, 3 dB cuts. And I'm trying to make the notches as tight as possible so I'm not pulling out too much of the audio spectrum. Now this next row is what I'm going to tune the handheld with. .153, so I'm going to hit the divide button. Bring up a little bit more. I won't do too many notches on the handheld because we won't need it. 467. We'll come up to the lapel. We had like the lapel here, we had a 460, so I'm going to widen the Q. So rather than doing 2 notches at neighboring frequencies and potentially over notching, I just widen the notch of this and do just a little bit deeper of a cut. We'll do 1 more notch on the handheld. .23. Oh, there's another frequency under there. 17. It is 17 here. Okay. So now we have 7 notches. We have a nicely shaped system, and then we have a nicely notched system here. Another mistake I see that people make, if a system is primarily used for speech, they'll try to tune systems using music, and music is going to hide a lot of problems. Music is a lot more forgiving, and when you're trying to use a microphone in a live application, music's not going to be a great test because it's not going to be live instruments that you're trying to get to reproduce in the same room. So if you're tuning a system, you need to tune the system for the type of content. You need to tune the system with the type of content that it's intended for. So since this is primarily a speech system, I'm not going to use music to base my tuning off of. I'm going to use the microphones that are going to be used in that room. Now I am going to use music as a reference because I know how certain songs should sound, so it's a reference point, but it's not how I tune the system. So next time you're confronted with analog equipment, a third octave equalizer, a compressor, even a notch filter, you'll have a better understanding on how that works. Now, I want to give you a sneak preview of a up-and-coming video. Let me show you our live stream room. I know a lot of you ask about live stream and you have no idea where to start. Well, we were there too once, and I want to show you what we do